Greetings students. I have already sent you the PPT and notes of this chapter number system last week. Now we'll begin with the exercises. So we'll start with the first exercise. I hope you all have gone through the given PPTs and notes, and it will definitely benefit you, and you will understand most of the concepts related to this chapter through those PPT and notes. Let's begin without wasting any time. The first question of this exercise is 0 a rational number? Can you write it in the form P upon Q, where P and Q are integers and Q is not equals to 0? So yes students, first we need to understand that what is a rational number. What are rational numbers? So rational numbers are the number which can be expressed in the form P upon Q. So can we write 0 in the form P upon Q? Yes, 0 can be written as 0 upon 1. Since 0 can be written as 0 upon 1 and even as 0 upon 2 and any number below 0. So since it can be expressed in the form P upon Q, so it is a rational number. Yes, 0 is a rational number. So the answer for the first part of this question is 0 a rational number? The answer is yes. Can you write it in the form P upon Q? So see, we have written it in the form 0 upon 1, where P and Q are integers. 0 and 1 both are integers, and yes, the denominator, which is Q, and here it is 1 or 2, is not equals to 0. Now let's see the second question. Find 6 rational numbers between 3 and 4. So my dear students, there are infinite rational numbers and even numbers. There are infinite rational numbers between two numbers, right? And here though we just need to find 6. So how we are going to find those 6 numbers? Now the first step to find any number of rational numbers between two numbers is to make the denominator same. Here between 3 and 4 we can write 3 as 3 upon 1 and 4 as 4 upon 1. Here the denominator is already same. If it is not same, then we need to convert this denominator to the same number by using the LCM property. Like for example, the denominator of one number is 2 and another is 3. So what we are going to do, we will find the LCM of 2 and 3, and the LCM of 2 and 3 will be 6. So we will convert both the numbers to 6 by multiply 3 to 2 and 2 to the number 3. Here the denominator is same, so this step we are going to skip. Now the second step is, here we need to find 6 numbers. So whatever number of numbers we need to find, we multiply the given numbers by the successive number. So we multiply the numbers by 6 plus 1. Because here we need to find 6 numbers, so we are multiplying by 6 plus 1. If we need to find 10 numbers, so we should multiply it by 11. If n numbers are to be found, then we will multiply it by n plus 1. So here 3 upon 1 will be written as 3 upon 1 into 7 upon 7, and this 4 upon 1 can be written as 4 upon 1 into 7 upon 7. So you might be recalling the concept of equivalent fractions. So here if we write 3 upon 1 or I write 3 into 7 upon 1 into 7, both are same by the concept of equivalent fractions, which you have already studied in your previous classes. So these numbers will become now 21 upon 7. This 3 into 7 upon 1 into 7 become 21 upon 7. And 4 upon 1 into 7 upon 7 will become 28 upon 7. Now, can you see 6 numbers between 21 and 28? Yes. So those numbers will be 22 upon 7, 23 upon 7, 24 upon 7, 25 upon 7, 26 upon 7, and 27 upon 7. And it is between 21 upon 7 and 28 upon 7. So the required numbers are 22 upon 7, 23 upon 7, so on up to 27 upon 7. 21 upon 7 and 28 upon 7 were not required because we were requiring numbers between these two numbers. Actually, this 21 upon 7 is nothing but 3, and this 28 upon 7 is nothing but 4. So I hope now you have understood how to find any number of numbers between two numbers. Now, the next question of this exercise is here on your screens. Find 5 rational numbers between 3 by 5 and 4 by 5. Hope now you are getting, now you are understanding this, that this question is exactly same what we have done in question number 2. So, this question is for you now, and it is your homework. So you are going to do this question yourself, and you can discuss this question. If you don't understand, or if you are not able to do this question, then you can discuss this question with me through Google Classroom. Right? Now, let's see question number 4. Question number 4 is state true and false. I have written in short, state true and false with reasons. So we'll be discussing here every natural number. First question, every natural number is a whole number. So students, first of all, we need to understand what is a natural number, what is a whole number. So my dear students, natural numbers are the numbers which can be counted, like 1, 2, 3, so on up to infinity. These are natural numbers. Counting numbers are called natural numbers. And what about whole numbers? Whole numbers are the numbers, whole numbers are the natural numbers including 0. Yes? So whole number includes 0 as well. So every natural number is a whole number. The answer will be true, because yes, all the natural numbers are whole number, and even whole number include one more number, which is 0. Now let's come to the second question, second part of this question. Every integer is a whole number. My dear students, integers are the numbers including positive numbers, including negative numbers, and 0. But whole numbers, do whole numbers include negative numbers? No. So every integer is a whole number? No. Why? Because let's take an example. -2 is an integer, but -2 is not a whole number, right? We can say that every whole number is an integer. Yes, every whole number is a integer, right? So let's see this third part of this question. Every rational number is a whole number. What do you say? What are rational numbers? We had already discussed this in question number 1. Rational numbers are the numbers which can be expressed in the form P upon Q, fractional form. But say let's take an example, 2 by 3. Is 2 by 3 a whole number? No. 2 by 3 is not a whole number, because whole numbers are the numbers like 0, 1, 2, 3. It does not include decimal numbers. It does not include fractions. Right? So the answer for this question will be every rational number is a whole number. The answer is false. Right? So with this was a short exercise. We have done this exercise now. I hope you all have understood this exercise, and in the next video we'll come up with the next exercise. Thank you. Stay at home. Stay safe.